Hello ladies and gentlemen, today we are talking about section 8.3, which is using properties to identify parallelograms. So now we're going to take a look at some quadrilaterals and identify, is this a parallelogram or is this perhaps something else we haven't talked about yet. So for this one, is Mark a parallelogram? Well, as it is, we have no information in this picture to help us conclude one way or another. Since we can't assume it's a parallelogram, we would say no. However, if I did something like this, and I marked that the opposite sides were congruent, now we have some information to work with. We know from section 8.2 that in a parallelogram, the opposite sides are congruent. So we can take the converse and use that as well. If opposite sides are congruent, then we can deduce or conclude that this is a parallelogram. So we have some sort of evidence to base our conclusion. There are several theorems and several ways we can conclude if something is a parallelogram. The definition says if you have opposite sides that are parallel, that's a parallelogram. That was from section 8.2. That's just the basic definition of what a parallelogram is. There's a couple other ways as well. Theorem 8.7, which these numbers are important to note, if the pairs of opposite sides are congruent, then it's a parallelogram. Again, as long as this is a quadrilateral. Excuse me. Also, if opposite angles are congruent, we know this is a parallelogram. So if both pairs of opposite angles in any quadrilateral are congruent, then you know it's going to be a parallelogram. So if you want to pause and copy these down, you can, but I'm going to move on to do some examples. So in quadrilateral WXYZ, the measure of angle W is 42, the measure of angle X is 138, and the measure of angle Y is 42, all these being degrees. Find the measure of angle Z. Then we will answer the question, is it a parallelogram, and explain your reasoning. So I'm going to draw this out first. Some quadrilateral, and when we list the letters, we always go clockwise. We know that angle W is 42, angle X is 138, the measure of angle Y is 42. We want to find the measure of angle Z, I'll call that X. Now, we know from section 8.1 that to find the measure of the sum of the interior angles of any polygon, any convex polygon, we use the formula n minus 2 times 180. And we have four sides here, so 4 minus 2 times 180, which is 2 times 180, which is 360. Now I did that quickly because many of you probably already remember that a quadrilateral always adds up to 360, much like how a triangle always adds to 180 degrees. So all of these together should add to give us 360. So I can say, well, if I add 42 and 138, and my other 42 and my X, that should equal, 360, because this is a quadrilateral. And from here we can combine like terms, and you might not have wrote this out. Maybe you just did this in your head and combined like terms first. And you said, well, 42 plus 138 plus 42, that's going to give you 222. One moment, sorry about that. And then subtract 222 from 360, which many of you might have done in your head, and you end up with 138. So that means X is 138. So there's the first part of our problem answered. And that part so far has been a review of what we covered in 8.1. The new stuff, is this a parallelogram? Explain. Well, looking at it, I would conclude yes. Yes, it is. How do you know that? Well, my two pairs of opposite angles are congruent. And by theorem 8.8, that means it's a parallelogram. So I would say yes, and I would either say that opposite angles are congruent, or I could just say theorem 8.8 in sentence form, but since I'm talking to you now, I won't write that in sentence form for the sake of time in this video. But I would expect you, and it says explain, write a complete sentence. Let's move on. The two final ways you can tell if a quadrilateral is going to be a parallelogram is the first one pair of opposite sides of a quadrilateral are congruent and parallel. So these two lines are parallel as well as congruent we can conclude it's a parallelogram. The second one, 8.10, we've already seen somewhat from the last section of notes, that if the diagonals bisect each other, these halves are congruent to each other, we know that this quadrilateral is going to be a parallelogram. And if you're interested in how these are proved and how these were actually proved by Euclid or other mathematicians in the past, feel free to come see me before school or after school or send me an email. I would love to talk about it, but for the sake of this video staying concise and short, I'm going to skip the proofs for now. So, what theorem can you use to show that the quadrilateral is a parallelogram? I'll pause. You might want to pause it just for a moment if you want to work this out on your own, and then we can go through the results if you want to hit play again. So I'll give you a moment to pause it if you'd like to pause it. All right, so looking at 2, we know that we have a pair of segments that are 30 meters, and that same pair of segments, those are parallel. So that is going to be theorem 8.9, which states that yes, it's a parallelogram. Opposite sides are congruent and parallel. For number 3, we have 2 pairs of opposite sides that are congruent. We have 5s and 7s. That's going to be theorem 8.7. That theorem says that if we have 2 pairs of opposite sides congruent, then the quadrilateral is a parallelogram. Much like theorem 8.8, which says if we have 2 pairs of opposite angles that are congruent, we have a parallelogram. So theorem 8.9, excuse me, 8.7 and 8.8. So those are some basic things to be able to tell if something is a parallelogram. We'll go through more complex problems in class, but if you are absent, this should be sufficient to catch you up. And if you have any questions, as usual, please email me or see me before or after school.